What is potential difference in electricity? The term implies a difference between two potentials. But what is potential? Do different points in a circuit have different potentials? Intuitively, that must be the case. If not, the term potential difference, a difference in potentials between 2 points, would not have been coined. Is potential at point A the same as B, C, or D? If the potentials at A and D are different, we said there is a potential difference between A and D. If the potential difference between A and D, VAD, is equal to 8 volts, what are the possible values of potentials at A and D? Write your values on a piece of paper and check with the possible answers mentioned later. Please start writing now. If the potential at A is equal to 8 volts, what will be the value of potential at D? It is 0 volt. 8 here, 0 here. If the potential at A is equal to 2 volts, what will be the value of potential at D? It is minus 6 volts. 2 here, minus 6 here. What if the potential at A is equal to 0 volt? What is the potential at D? It is minus 8 volts. 0 here, minus 8 here. If you have any slight doubts to the last two questions, you should continue to follow the video. What does the value of a potential mean? For example, a potential of 8 volts. Give it a try. What does a potential of 8 volts tell us? Well, the value of the potential 8 volt implies 8 joules per coulomb. That is, 8 joules of work done by an external body is required per unit charge to move the charge from infinity to the point where the potential is 8 volt. You have to do some work to move the charge. Hence, 8 volt can also be referred to as 8 joules per coulomb. The next relevant question to ask is, where has the work done by an external body gone to? For the case of 8 volt potential, the 8 joule of work done is converted to electric potential energy of the charge. This implies the charge at the 8 volt potential point has 8 joules of electric potential energy. If the point A has 8 volt potential, this implies the charge has 8 joules of electric potential energy. What can this electric potential energy make the charge do? To help you, as an analogy, what will happen to an object with 8 joules of elastic potential energy? An example of an object with 8 joules of elastic potential energy is a block attached to an extended spring as in the picture below. How do I know that the block has elastic potential energy? Well, the block moves to the left if it is released by the hand. Elastic potential energy has been converted to kinetic energy. The 8 joules of elastic potential energy of the block has been converted to 8 joules of kinetic energy of the block in this case. That is, if the surface is frictionless. If the surface is not smooth, part of the elastic potential energy may dissipate as heat energy through friction. Similarly, 8 joules of electric potential energy of the charge at point A enables the charge move around the circuit to B, then C, and D. In the process, the 8 joules of electric potential energy is converted to other forms of energy. What can the charge at A do with this electric potential energy? At point A, the charge has 8 joules of electric potential energy per coulomb. Similar to the case of an object with elastic potential energy, the object will move off as its elastic potential energy is converted to its kinetic energy. It will allow the charge to move along the conductor if there is a conduction path. As the charge moves along the copper wire from point A, do you think its potential at C is higher or lower than that at A? Think about the electric potential energy of the charge at C. Do you think the charge at C has higher or lower electric potential energy compared to those at A? It should be lower, but why? Potential at C is lower than that at A. As the charge passes through the variable resistor, part of its electric potential energy is expended as heat energy and dissipated away. Hence, the charge at C has lower electric potential energy and therefore a lower electric potential. Similarly, potential at D is lower than that at C. As the charge passes through the bulb, part of its electric potential energy is expended as heat energy and light energy. Hence, the charge at D has even lower electric potential energy and therefore an even lower electric potential. As the charge moves along the copper wire from point A, do you think its potential at B is higher or lower than that at A? It should be the same, as no energy is expended as the charge moves along the copper wire from A to B. What about a point C? Ground point C to zero potential, that is, make point C at 0 volt. Does doing so take energy away from the circuit? One certain conclusion is grounding point C should not change the 8 volt EMF of the cells because grounding C to 0 volt performs no external work and that should not change the energy situation in the circuit. Will point A has a potential of 8 volt, point D a potential of 0 volt, so that the EMF of the cells remain at 8 volt. Think about that. There is no way for D to have a potential of 0 volt when C is at 0 volt. Why is that so? Well, as the charge moves from C to D, similar to our argument before, there is a loss of electric potential energy to other forms of energy after passing through the bulb. Since there is a loss of electric potential energy, D should have a lower potential than C. If C has 0 volt, D should have a potential lower than 0 volt. So, what is the possible value of potential at D?